I gave you one worksheet and notes on kinematics. Did you see that one? Karim?
Yes, sir. I'm going there.
Yeah, here you.
Yes, sir. I think I had it. Sir, এটা তো আপনি আগেও দিয়ে
Yeah, I gave it earlier, but I expected you to do it, the worksheet.
Yes, sir. I
after
did it. I did
So,
it.
did you
I
send
need to
me?
send it. Sorry, sir.
Did you send me this one? The worksheet.
Really sorry, sir.
Hmm?
Sir, actually, I finished it just yesterday.
So, you have any queries on the notes?
Yes, sir. It's the third question, I think.
No, I am asking
Only
you
the
about
third
the
question.
notes. Listen, one by one we will go. Okay. First, tell me these notes. You have any queries or not? Did you go through the whole notes?
Yes, sir. Kind of.
Kind of. If you are saying kind of, then I have to go with all. Without going through all these things, we cannot solve the worksheet. If you say that yes, you are confident enough about this notes, you have all these ideas, then we can go for the worksheet. As you told me that you are done with all
Sir,
these
we
things.
can just try page number 7. Notes.
Notes. Okay, try page number 7. That one has
Yes, sir.
numericals, right?
Yes, sir.
Okay, very good. So you try it right here. Right here. Do it. The question is here. The first question I'm asking you. The
No, sir.
distance.
The above one. The above one as well.
This one.
Yes, sir. This is page 7, right?
Okay, this page one.
This whole page.
Okay, this whole page you want, right?
Yes, sir.
So this one uh, is velocity time graph, right? And
Yes, sir.
in velocity time graph, the area under the graph is giving you the displacement.
Sir, is it displacement or distance?
That's why I wanted to discuss from the beginning. As you are
Sir, the
confused
perimeter
about,
gives us the distance, isn't it?
listen. Here we have the ideas. Look, the definition of speed and velocity. Can you read speed?
Yes, sir.
Read loudly.
Sir, speed is the distance moved per unit time.
And velocity?
Velocity of an object is the rate of change of displacement with the rate respect to time.
So velocity is displacement over time, and speed is distance over time. Speed is vector quantity because distance is vector quantity, and velocity is speed is scalar quantity. As distance is scalar quantity, and velocity is vector quantity as displacement is vector
Displacement
quantity.
is a vector quantity.
So is it clear? When we
Yes,
are
sir.
getting velocity time graph, that time we are getting displacement area under the graph. If it is speed time graph, then we are getting distance traveled. Is it clear? The thing is almost similar, but there is little bit difference. That is distance, it does not have any direction, but Displacement, when we are getting that one, has direction.
Okay, sir.
Now this one, the area under a uh, speed time graph, here we are getting, sometimes they are writing this way, mixed up. They are writing here velocity time graph, but they are also writing here distance traveled. But it should be displacement traveled. That will be appropriate. Okay. If it is speed
Sir,
time
why
graph,
displacement, not distance?
because displacement has direction and distance does not have direction. I said more appropriate. We accept it sometimes, but in numerically it's accepted. But if there is anything related to direction, that time it will not be accurate.
Sir, actually, in the velocity time graph, do we talk about, means most of the time, do we talk about the direction?
Yeah, it's here we are neglecting it or we are omitting it. But from the you know point of physics, or the from the scientific uh, point of view, we should write here displacement. That will be more accurate. Got it?
Okay, sir.
We ignore it or we neglect it, but that's not accurate. That's not appropriate. Okay, is it clear?
Yes, sir.
Okay, now speed time graph. We are getting here constant acceleration graph, and area under this graph is a triangle, right?
Sir,
And that's why we are using the formula of triangle, half into base into height. So your base is here 5, and speed is the height is here 50, and 2 is there for the formula. So the distance moved, if you calculate, it is 125. Now
yes,
another thing I'm showing you, that is related to units. Here we got h, the one height, that is speed, right? In meter
yes,
per second. And the one is base, that one we are getting in
from
seconds.
time.
The time is given in seconds, right? So it is 5 seconds. Is it clear, Karim?
Yes, sir.
So here we can cut this second as second. So the unit left here is meter, right?
Yes, sir.
And meter is the unit for distance traveled. That's why we are going to that decision or conclusion that if you are getting the area under speed time graph, that's giving you the distance. So you got the proof how it is distance traveled, Karim?
Yes, sir.
Now we are going for next question. That one you will do.
The most difficult part of the study.
No, it's not difficult part. It's the more interactive part, right? This one. Uh, First we have constant acceleration, the way you got before, part A, and then second part, what you are getting?
So constant speed,
Yeah, constant speed or constant velocity. Then this part,
constant deceleration.
deceleration. You say deceleration, not deacceleration. Say what? Constant. This part C is constant. Hello. Karim,
Yes, sir.
pronounce again. Constant.
Deceleration.
No, no. Deceleration. Say constant
Or
deceleration.
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 Sir, isn't it the same thing? Just
No,
we
no,
add
no.
this so
Don't
that we.
don't say that one. Just say the one we are using, familiar with. Deceleration. If you say this de-acceleration to other people, then they will say, they will comment that Shajan sir taught you this de-acceleration. Say deceleration.
Deceleration.
Excellent. So now you find the distance traveled after 10 seconds. Can you calculate it? How much it is? And tell
Yes,
me.
sir.
Distance
It's
traveled in part
10
A.
by 20 into 100. 10 plus 20 into 100, which is equal to 15. 15 plus 20 into 20, which is equal to 400, is 415. 415 plus. Okay, so let me use the calculator.
Are you calculating for the whole part?
No, sir.
Only for part
Sir,
A. Only for part A.
sir,
You
it's
calculate.
15.
It's how much?
15, sir.
How 15?
Sir, we are finding the.
Area under the
Oh,
graph.
sir, isn't it 10 means,
Half into base
base
into height.
plus height divided.
Yeah, base into height
Oh,
divided by
oh,
2.
okay, sir, okay, sir. It's 150.
Why 150?
So 20 into 100. Okay, sir. Uh, I was just trying mental math, sir.
Yeah, yeah, do it quickly. Part A. Part A, we
Okay,
are
sir,
getting
it's 100 at
it's
last.
100. At last you got it, 100. Then for B, part B, how much?
So part B,
Hmm.
we will get 20 into 20, which is equal to 400 divided by 2 is equal to 200.
Why 200? What
So
is
it's
the
20 into
area under the
20.
graph? It is
So
rectangle,
200,
right?
400.
Yeah, it's 400. That's
400 divide.
why divided
Oh,
by?
I did it by.
Why
Sorry, sir.
divided by? It's not triangle, right? It's
I did that very
rectangle.
mistake.
So it will be 400 only. Then C, part C. Part C, how much it is?
Part C. Okay.
Mhm.
It's 20 into 4800 divided by 400.
Yes.
Sir, 400.
Again 400. Okay. So it is 40, 20 multiplied then divided by 2. Yes, 400 again. So what is the average speed for the whole journey?
Sir, we will just add them up, which we will get 900.
Mm-hmm.
So we will just add them up
Yeah, that is total
because we have
distance.
find the area of ABC, and A plus B plus C is equal to the whole journey.
Yes, this one is the formula, right? So can you tell me what is the average speed for the whole journey?
Okay, 900 divided by 70, 90 by 7. Sir, it would come in points.
No problem. Tell me the points.
No, sir, I was just trying mental math.
Three significant figure.
12.85714286.
Again,
12.85714286.
I told you three significant figure.
Okay, sir. 857.
857. That means we can write 12.9, right? Meter per second, right?
Yes, sir.
Or meter?
Sir,
What?
meter per second, because
Okay.
there was no meter per
Distance,
second
yeah,
divided by
distance
second to
over
cut the
time.
second.
Yes,
Yes,
very
sir.
good. Now, this part is done. Any queries here? You have
Yes,
any
sir.
queries here?
No, sir, it's cleared.
If it is clear, then we
Sir,
are
would you
good.
give me 20 seconds? Because I need to drink a bit of water. I'm thirsty.
Yes, have 30 seconds.
Thank you, sir, for the 10 seconds.
Yeah, of course.
Yes, sir, I'm back. Did I take much more time?
No, no, it's fine. So now this one, you will solve. There are some questions here. You will tell me the answers. Huh? Can you read it, or should I make it bigger for you?
No,
Yeah,
sir, I can.
yeah, yeah. Continue.
Which question? Okay, sir, let me read it from the beginning.
Yeah,
Sir,
read it.
could you just minimize it because I can't read? Yeah, yes,
Now
sir.
it's fine.
A speed time graph is shown for the journey of a London tube train between two stations. This is the journey for a tube train between two stations. And in the first question, we need to match the journey phase with its line on the graph. Sir, I didn't understand the question.
This one, first question you did not understand.
Yes, sir, the phase word.
Hmm. So, which one decreases speed? Which part?
So it's the first part. This, okay.
Read
Okay, it's for the last part.
last part. Yes, decreases speed to approach the next station. Then next,
It's depart the station and increases speed for 30 seconds.
yes, which part?
So it's for the first part.
Very good. Then the last one is for second part, right?
Yes, sir.
Then continue. Next question.
Okay, sir. It's find the acceleration over the first 3 seconds.
3 or 30?
Sir, it's 30 seconds.
Mhm. How to find the acceleration? What is the formula of
Sir,
acceleration?
we can divide the change in velocity by time.
Mhm. So what is the change in velocity?
Sir, it's speed, meter per second, the change in velocity, and time is time. So it would be a meter means meter by second divided by second, meter per second square.
So what is the answer?
So 60 divided by 30 is equal to 2 meter per second square.
Yeah, continue next. Thank you.
Find the retardation. Oh, what is retardation, sir?
The one you said, deceleration.
Okay, sir. The retardation over the final 70 seconds. Okay, final 70 seconds. Sir, isn't it
It should.
60 seconds?
Yes, yes. There is some correction. You take it as 60 seconds, not 70.
Sir, then would it be meter per second square inverse means meter per s to the power minus 2?
Mm-hmm.
Then it would be 60 divided by, sir, it would be 1 meter per second per meter second to the power minus 2.
Mm-hmm. Okay, very good. Then 4.
4. Find the total distance traveled. So we got 30 from here, 80, 50. So 50 into 60 to 60 is equal to 300. 300, 300 plus, okay, I need to calculate. It's 300
Hey,
plus,
Ekram.
which I
Huh?
just found was
Table
one.
sit there.
Sir, the constant speed would be 300 meter per second, 300 meter.
How?
And sir, because we need to just find the area and it covers from 30 to 80. And 80 minus 30 is equal to 50. 50 into 60 is equal to 300.
So they are asking you to find the total distance traveled.
Yes, sir. Oh, sorry, sir, it's 3000.
How it is 3000?
Sir, 15 to 60. 5 into 6 is 30. And the two zeros beside them is it, we will add those zeros to it. Just place those two zeros beside it. Then it's 3000, 3000, and which I find the acceleration is 2 meter per second. We got it for acceleration 330 seconds. 60, 60, 60 plus 60. Okay, plus 60 plus 60. So it should be 300 and 300, 3120. Am I correct, sir?
Let us check. 3000.
120.
You are saying 3120. So I'm doing it. Huh? It's area of trapezium. For the whole one, we can directly do area of trapezium. You know that, right?
Yes, sir.
Trapezium. What is the formula?
So the formula is A plus B divided by 2 into height.
Okay, this
The
way we
height
can
is
also
60.
write A plus B, then H, right? This way you can
Yes,
write.
sir.
So we put the values half, then A plus B. What is your A?
Sir, A is 50. The constant speed.
Yeah, 50. So this one is from 30 to 80. So it is 50. Very good. And B is how much?
Sir, B is 140.
Excellent. Then 140. bracket closed, then times height. Height is 60.
Yes, sir.
Okay. Then it's coming how much? 50 plus 140 is 190, right?
Yes,
190
sir.
divided by 2. That is giving you 95.
5,700, sir.
95. 95 multiplied by 60. How much it is?
5,700.
5,700. And the unit should be meter, right?
Meter per second.
Distance traveled,
Okay, sir. Meter.
meter per second multiplied by second. It's coming meter. Again, I am showing you how it is meter.
But sir, can't we just মানে আমরা কি ট্রায়াঙ্গেল রেক্টাঙ্গেল এভাবে করে করলে আনসারটা ডিফারেন্ট কেন আসবে?
You did
নাকি
some
আমি ভুল
mistake.
করছি?
You did some mistake.
Okay.
Yes.
Oh, I find my mistake, sir. Silly mistake.
Hmm. Look, A plus B. A and B, you are getting the time, right? Hello?
Yes, sir. I'm there.
Yeah. Time is second, then height is meter per second. So you are getting meter, right? Again. Second cut, meter is left. Is it clear now? How it is
Yes, sir.
meter? Distance traveled. Huh? If you are taking area under the graph, it will come meter only, not meter per second. Done?
Yes, sir.
Okay, great. Do you think it is useful for you? The class is going on?
Yes, sir.
Okay. Now continue. You have to read this one. Acceleration of free
Oh,
fall.
sir. I read this one.
Especially this part, the last part.
The magnitude of the gravitational acceleration of the Earth is determined by the mass of the Earth
Yes.
and not by the mass. So I didn't understand this.
Yes, that's why I told you to read. Read completely.
Means that a feather and a blowing ball will fall same way with a greater resistance. So, sir,
Okay,
why did we took bowling ball?
I will start the discussion by a question that is on moon. What is the?
That was question 4, sir. No, sir, that was question 3.
No, I am asking you with a question now from me, not from the worksheet. That is on moon, the acceleration of free fall is 1.6, and on Earth it is 10, right? 10 meter per second square. On moon it is
So it's not
1.6.
actually 10, it's 9.7 something.
9.8,
9.
9.81. So we are rounding it up as 10, okay, 10 meter per second square. And on the moon it is 1.6. So why it is different? Why it's not same on Earth and moon?
Due to their mass.
Because of the mass of the moon, because of the mass of the Earth. Okay, and mass is coming from this formula. You know, rho equals m by v, right?
Yes, sir.
So your mass is coming from the density of the material available in the earth and its volume. Okay, similarly for all the planets, all the heavenly bodies, all the satellites, for all of them, the same rule. Okay, that is their mass. Their mass is the responsible thing for creating the gravitational acceleration. Okay,
Yes,
is it
sir.
clear? And if there is no air resistance working, any object you are dropping from the upwards, they will fall with the same acceleration. Okay,
Why, sir?
it's not depending on their mass or their size or their volume. Every object, if I drop you from 5-story building, the way you will go down the acceleration, the same way an ant will go if there is no air resistance working. Okay, because the acceleration depends on the attraction from the earth. Okay, the force due to the gravitational force coming from the earth core. Is it clear to you?
Yes, sir.
And now in our daily life, we see that feather is falling later. It is because of the air resistance. Air resistance is opposing the motion. That's why it's falling later. But if you are giving one completely air-free environment, then
Means
you will see,
vacuum.
yeah, vacuum. There is one experiment you can check out in YouTube. That is Galileo's experiment. Okay, that experiment is available in the YouTube. You can check it out. Inside the vacuum, they are dropping one feather and one steel ball. Okay, and those two are falling in the same time and hitting the ground in the same time. Is it clear?
Yes, sir.
Okay, so I suggest you to go through again, not kind of. If you are going kind of, then you see many things you learned today. Learn means you, some of the things you got revised, you recalled, those are now working, and some of the things you got really new. Okay, like this one. Is it clear?
Yes, sir.
Okay, now we are going to the worksheet. Uh, I want you to go through this notes again because there are many things I gave here about especially about the motion graphs. These things, you should try to understand them. I know that you know them, but there should be some revision. If there is revision, then you can recall them quickly. This one like is one of them. Like you have here distance time graph. One is more steeper, another one is less steeper, right?
Yes,
Hello?
sir.
So the more steeper one is faster constant speed, and less steeper one is slower constant speed.
Means they will reach the means
Yeah, if
with
you,
every second they will differ from a certain amount of distance.
yes, yes. So from the shape of the graphs, we can understand which object is going faster and which one is going slower. Okay, then here we have, look, this type of graph, and also
So you
in,
can just move the animations.
hmm, I am, look, in distance time graph, we have this shape, and also in velocity time or the distance speed time graph, we have this shape. So for velocity time graph, it is uniform velocity, but for distance time graph, the object is stationary.
Sir, I
Sometimes,
have a question.
hmm,
They have given us a graph and they have just drawn this line without giving us the values like it is distance or velocity. But they gave us meter per second and time, means on their correct position. So how will we just find that which one is velocity and which one is distance?
look, this one, if it is given in meter per second, that means it is velocity time graph. If y-axis is given only meter and x-axis is given only time, then you are getting meter and time, that means distance time graph. If you are given here meter per second and here you are given second, then it is speed time graph. Is it clear now?
Sir, could you just explain me the speed time graph and velocity time graph difference again?
Okay, velocity time graph and speed time graph, uh, like it happens, this is the velocity, this is speed time graph. Okay, if one object is dropped, if one object is dropped from,
Sir, you can also use text, means you can just type, then it would be easy for you.
which one?
Like this. See? Uh,
Which one?
okay, I think I can.
Yeah, typing. Yeah, typing
The
also can be
text
done.
part.
Like, yeah, text part we can do. Yeah, look, I'm just going faster. In our worksheet, I will show you mainly how the speed time graph and velocity time graph is different. However, I am giving you little bit idea here. Like if one object is dropped uh, downwards, it's going down, that time both velocity time and speed time graph are same. But if your condition is like that, that one object is thrown upwards and it's returning back, that time your velocity time graph is like that. Here is minus, right? Hello?
Yes, sir. Sir, what if
You,
we took going upwards as positive velocity?
yeah, the going upwards, we are considering it as positive velocity. That's why coming down, we are considering it as negative velocity. If you are taking one as positive, other one will be negative. For that reason, you
Is
can take,
velocity time graph always like this, from positive to going negative?
yes, we normally consider this way. We normally consider this way. We have one question in worksheet. That one when we'll discuss, then it will be more clear to you.
Yes, sir. It was that if
Hmm.
astronaut throws a ball
Yes,
towards
yes,
the
yes, yes, yes. Like that. Like 3 seconds. What will be the shape of the graph in after?
no, sir. It was 6 seconds.
Yes,
They
six
gave us two
seconds.
seconds graph.
Yeah, and it's crossing in 3 seconds. That means the maximum height is 3 seconds. We are going there. We are going there. You will understand it then. Okay.
Sir, could you repeat because there's a lot of sound in the background for which I can't understand.
No problem. In worksheet, we are repeating it. What I am saying that in our worksheet, we got after 3 seconds, the velocity is 0, right?
Yes, sir.
In our worksheet, I am going to the worksheet. Here is the worksheet. We are talking about this one, right? This one, right?
Yes, sir.
So here, if you continue the graph, you will see that the graph is cutting this x-axis in 3 seconds. In 3 seconds, the velocity is 0. That means the stone reached maximum height where the velocity is 0. Got it?
So it would be 3.
Yes, it would be 3. 3 seconds. After 3 seconds, it reached to maximum height when the velocity is 0. Clear to you?
Yes, sir.
That one I was saying. Now, what I want you to do the whole worksheet.
Oh, sir, I just didn't did question 3. Shall I send you that?
Till question,
I did till question 4 except question 3.
all the MCQs are done.
Yes, sir, all of those except question 3.
So, question 3, what is the problem?
I can't understand that, sir.
Okay, we can go through now. Then you complete it and then send me. Yeah,
Okay,
question 3,
sir.
can you read it?
3. A ball rolls down a shape as shown in figure 3.1. The meter rule shows the position of the ball at time t is equal to 0, t 1 and 2 and 3. And we are given all those information in this diagram, which is figure 3.1. In question A, we are said that explain how figure 2.1, it's actually 3.1, shows that the ball is accelerating.
Yeah, uh, how you are getting the information in 1 second. First one
Sorry, it is
second.
covering more distance at a same period of time.
Yes. Hmm. So you told the correct thing. You just read. You just write that one. Okay. What you said that is correct.
The main problem is with B, and B is connected with C.
Yeah. Uh, read it. Then find it. Calculate the average speed. Right. Can you
Yes,
read
sir.
it and do it?
Sir, the average speed was 10 meter per second as I did.
How
Because,
how you write here? Write here. How you did 10 meter per
okay, sir.
second. By text, you can do text, right?
Yes,
Text
sir.
form. That will be easier to do quickly.
Annotate text. Okay, sorry, sir. Uh, okay. It's, sir, can you see?
I can't see.
Because, yes, sir, it's too
Now
small.
I can see. Now I can see 100. You wrote 100.
Yes, sir. 100 minus 10. Okay, sir. Not here. Uh, okay, sir, I need to write it.
Okay, look, I understood what mistake you did. Already you wrote something that from there I understood. Though it's not visible now, I understood the problem. They are saying you in between 1 second and 3 seconds, right? So
Oh,
here,
sir, I wrote -3, but it should actually be 3.
okay, look, you look at this one, 3, 2, 1. So here we got 2 seconds, right?
Yes, sir.
2 seconds. Here we got 2 seconds, and the distance traveled within this range, it is uh, 20 to 100. So it is 80 centimeter. 80 centimeter,
Right,
right?
sir. We started rolling the ball from 10.
But they asked you about from 1 second and 3 seconds in between.
Okay, sir. Now I understand.
Yeah, that's the main thing. That's why I told you I understood your problem. Now you can do it, right?
Yes, sir.
You can do it now. 80 by
It would be 88 divided 78 divided by
why
84, which will
78?
get.
Why 78? It is 80 divided by 2.
No, sir. I'm doing the calculation.
Yeah, look, 40.
It would be 15 into 3. No, not 15. 26.67.
No, no, no. They are asking you to find the average speed for
Oh,
the
26.67 divided by 3, isn't it, sir?
no. Here, look, they are talking about average speed, right?
But so we have 3 seconds here. One, two,
Why three
three.
seconds?
Sorry, sir.
No, no, we have here only 2 seconds. Here is one. This is mark one. That means already 1 second done. If you start from here, then 3 seconds. If you start from
From
here, then
here.
it is 2 seconds. Okay, wait, 2 minutes. Azan.
Okay, sir.
Yes, Karim.
Yes,
Hello,
sir.
Karim. So you understood it?
Yes, sir.
How it is 2 seconds? Then total distance traveled from 20 to 100. It is 80, 80 centimeter. Then average speed is total distance traveled and time taken. It is 40 meter per second. Till now, is it okay? Is it fine? We can continue
Yes,
the
sir.
next part. Okay,
Sure, sir.
okay. We are going to next part. Okay, this one is done. Question 3 is done, right? You had problem with question 3. Question 4 is done by you, right?
Yes, sir.
You can do it. Okay, fine. Now, what I want, you will send me the worksheet by tonight. By completing
Okay,
the
sir.
worksheet, you will send me tonight, and we will discuss next topic. Yeah, that one dynamics in our coming class on Wednesday.
Sure, sir.
And before that, I will upload the notes and worksheet. You try it as much as possible. Huh?
Sure, sir.
As you are done with these topics before, you just have a look. If you have any doubts in the notes, you can ask me. Okay. So thank you so
Sure,
much.
sir.
And give my salam to your mom. Okay. Your
Okay, sir.
parents. Parents. Okay. Thank you so much. Allah Hafiz.
Allah Hafiz, sir.